In section 1.3, we are going to focus on using transformations of functions and taking a look at what they do to the graph as well as the domain and range. So go ahead and write this down, pause the video and write this down. But what I want you to notice here is that I don't actually have a specific function written down. So I don't have a square root or a quadratic or any of that type of thing. I'm just using a generic function f. Okay, so f of x, x being the input. So let me give you just a specific example so that you kind of can see what I'm talking about. So we could have something like f of x equals 5 times 3 quantity x minus 2 squared plus 1. So we do have a function in here, okay, the function being this quadratic. Okay, so our quadratic function. So then we can see numbers inside of that quadratic and then outside. So the numbers inside are 3 and 2, and the numbers outside are the 5 and the 1. So the numbers that are outside of your function, the a and the k value, those numbers are going to impact the range, which is the up and down, the up and down of the graph. Okay, so your y values move up and down. And then you have the interior numbers, or the numbers inside the function, and those numbers are going to impact the domain or the left-right movement of the graph. Okay, so outer numbers up and down for the range, inside numbers left and right for the domain. So our a value, and you can tell that it's the a value because it's multiplied by the function on the outside. So it's going to be multiplied or divided. Usually if it's divided, it'll be like 1/3 instead of divide by 3. But that's going to impact, it's going to be a vertical stretch or compress. So if we're talking a parabola, it's going to make the parabola skinnier. I don't want you to say skinnier, okay? So you're going to say vertical stretch by a factor of a, whatever that is. So in this case, it would be vertical stretch by a factor of 5. This means it's making it 5 times taller. Okay, when you move over 1, it's 5 times higher than it would have been originally. Okay, so vertical stretch. The compress happens when that number is between 0 and 1. So like 1/2, 1/4, 3/4. Okay, some fraction between 0 and 1. If the a value is negative, then we're also going to have a reflection over the y-axis because remember, it's moving the function up and down. Okay, so it's going to reflect it over the x-axis. And then if you have a k value or a number outside of your function that is added or subtracted, okay, outside the function added or subtracted, that's a vertical shift. Okay, so in our case, the 1 in this one. Okay, but that's going to be a vertical shift, and you'll say vertical shift of 1, okay, vertical shift up of 1 or whatever, vertical shift down 1 unit. Numbers inside the function, again, impact the domain, so the b value you're going to know because it's multiplied. Okay, and it has to be factored out. Do you see how I've got parentheses in here? Okay, so it has to be factored out. So if this one had been written like this, we would need to factor out this 3, okay, in order to write it in transformation form. Okay, so factor that out so you can get that h value correct. So this would be a horizontal stretch by a factor of 1/b. So this one is actually the stuff inside the function impacts the domain, and it's opposite of what you think. Okay, so if you're multiplying by b, then it's a horizontal or vertical stretch or compress by a factor of 1/b. So this one's going to be a horizontal compress by a factor of 1/3 since your b value is 3. Opposite of what you think for everything inside the function. So if that's a negative value, okay, so if that had said -3, then we'd also have a horizontal reflection, okay? So it's going to reflect it left and right, which reflects it over the y-axis. And then for if you have a number added or subtracted in there, that h value, it's going to be a horizontal shift. Okay, so it kind of looks like it says -2 in here, but there's already a negative in this formula. So this number that's actually in here is just a 2. So that's why I say kind of opposite of what you think, because it'll look like it's -2, but that'll be a horizontal shift to the right 2. Okay, so that value is actually 2. So that one's going to go to the right 2. Or if it said x plus 2 on the inside there, it would go to the left 2. So let's take a look at, let me write out a couple examples just so that you can maybe understand that a little bit better. So it, again, doesn't matter the function, so let me just give you some random ones. All right, so for these, so for this first one, so again, you kind of want to look for what the actual function is. So this is an x squared function. And then determine if the numbers are inside or outside. So we have this 1/2 outside the function. Okay, it is not inside of that squared. So this is an a value. Then the 3 is on the outside. So that's our k value. So for this one, we would say this transformation is a vertical shift up 3 units and a vertical compress by a factor of 1/2. You can say vertical stretch too by a factor of 1/2. I'm okay with that. So vertical stretch by a factor of 1/2 and vertical shift up 3 units. This next one, okay, we've got an x cubed function. So we see the cubed, that's our function, our parent function. So we've got the 3 outside multiplied, that's our a value. We've got the -4 outside, okay, that's our k value. And then we have -2 on the inside. So our b value, or sorry, our h value is 2. So we have a horizontal shift, okay, and it's to the right 2, because that's a positive 2, so to the right 2. Vertical shift down 4, okay, because outside impacts the up and down, so right 2, down 4. And then a vertical stretch by a factor of 3. Then this last one, you may or may not even know what the sine function looks like. That's fine. It doesn't matter. You just need to find the numbers. So we have the sine function. So we've got this interior. So the 15 is on the outside. Okay, that's your a value. You've got this 2 on the inside multiplied. So that's your b value. You've got the 90 on the inside subtracted, so that's your h value. And then the 45 on the outside, so that's your k value added. So we've got this 90 on the inside, so that's going to be to the right 90. A 45 on the outside, so that's going to be up 45, so vertical shift up 45. This b value on the inside here is going to be a horizontal stretch by a factor of 1 over b, so 1/2. It's on the inside, so it's opposite of what it seems like. And then this 15 is a vertical stretch by a factor of 15, so exactly the same thing. And then let's say this was negative. Then we would also say reflection over, now it's outside, so it's going to be up and down, so it's going to go over the x-axis. All right, so let's take a look on the graphs here. So again, like this doesn't even have a function. I mean, I would have to write out a piecewise function for it. So that's not important, but what we're gonna do is we're gonna take and do, so this we'll call it f of x. I wanna do f of x, let's say plus 3. So plus 3 just means you're gonna take this graph and literally just shift everything up 3 units. Okay, so it started where? Here. Okay, so it started here. So we're literally just going to take every point and move them up 3. Okay, so if you weren't able to just pick it up like I did, you would just count up 3 from each of these points. And then you could draw your new, you could connect those. Okay, so you're literally just going to pick it up and move it up 3 units. And that's how you do a vertical shift transformation. Okay, if I was going to do, let me make that blue. So then if I was going to do another one, let's say I was going to do negative f of x. Okay, so that's on the outside. So I'm just going to flip it up and down. So I'm just going to flip it over the y-axis. So you go ahead and just flip these the same amount over. This one's touching the y-axis, so it's going to stay the same. This one is up here 6 above the y-axis. So 1, 2, 3, 4, 5, 6 above. So now you're going to go 6 below. 1, 2, 3, 4, 5, 6 below. 3 above, 3 below. Okay, 1, 2, 3, 4, 5, 6 above. So go back down to 6 below. 3 below, so 3 above, and then just connect those. Okay, so then that would be your new, that would be your reflected function. Just reflects it right on over. Let's take a look at this one. So for this one, let's do, this can be the graph of, let's just call it g of x. So then let's do g of x minus 4. So for this one, you have an h value. Okay, so this is an h value. So this one is an h value of 4. So this is going to move it to the right 4. It's inside the function, so it's going to move it left or right. So this one's going to move it right 4 units. So then again, you're just going to pick up all of the points and move them 4 units. So I'm just going to do these 4 points, move them 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then you would just connect to get your new function. Okay, or like for me, I could just physically pick it up and go 1, 2, 3, 4, and then I have the new function. Okay, so inside the function moves it left or right. Okay, shifting it left or right. Then let's take a look at this one. So this one gives us the parent function 2 to the x. So this graph right here is the graph 2 to the x. And then we want to actually shift it using this. So this is a k value. So you're just going to grab the function. So this one can, I have it so it can move. So we can go 1, 2, 3, 4 down, and that's our new function. So literally just shifts the whole thing down 4. Then let's write a couple equations here for these. Okay, so what is the transformation? And we're just gonna, we don't even need to know. You maybe know this is the absolute value of x, but you probably don't know this one. Okay, so we're just gonna call it, we'll just call this one f of x, and we'll call this one g of x, and then we'll write the new function. Okay, so you got to figure out what's going on. So look at the vertex. Okay, this one shifted over. Okay, so the graph shifted over 5. So that's going to, and that's a left, right. So it's going to be inside the function. Okay, so we're going to need to put a minus 5 in the function, because remember, opposite of what you think. Okay, so to move to the right 5, the inside would say x minus 5. And then we need to flip this one over. So all this -5 did was moved it over. Now we need to flip it, and we need to flip it up and down. So an up and down change, okay, is an outside the function change. So this is going to have a negative outside the function. Next one. Okay, so just find a point that you can go and watch what it's doing. You don't have to look at everything, but if you can look at one point. Okay, so this point right here is the same as this point on this curve. Okay, oh, no, it's not. I lied. It's the same as this one over here. Okay, let's look at, it might be easiest to look at like this one. Flips up to here, okay? Or you can say this one. Oh, I was right. It is this one. I don't know what I'm talking about. I was right the first time. Okay. Pause. Get rid of this. Okay, so let's go with the first one I said. All right, so this one moves over to here and it flips. Sorry. Okay, so this one moves to the right 2 again. So we're going to take that g of x function, and we need to move it 2 to the right. So we're going to have a -2 on the inside. Okay, so it shifts over 2, and then again it flips up and down. Okay, so then this one also has a negative on the outside. So it doesn't matter what the function actually is. Like, you don't need to know the absolute value, any of that. Okay, just being able to tell me what happened and where those numbers go in the function.